Hi students, today the most important topic in the first chapter, that is how to prove the given number as irrational. Okay, so here before going to start the topic, you should know this theorem. Theorem 1.6, just to see the statement, you should remember the statement, that is enough to you. If p is a prime number, if p divides a square, then p divides a also. If p divides a square, then p divides a also. This is a small example here. 3 divides 15 square. Yes, you know that 15 square is 225. 225 is divisible by 3. 3 7s are 21. 15. 3 5s are 15. So 225 is divisible by 3. 225 is nothing but 15 square. 225 is nothing but 15 square. 15 square is 225. Okay. So 3 is dividing 15 square. 3 divides then 15 also. You know that 3 5s are 15. Yes. So when a number prime number p is a prime number and dividing square of a number, then that divides its base also. Okay. So p divides a square, p divides a also. So this is useful in proving given number as irrational. So we go to the topic now. So proving irrationals, especially what models are there? Let us see here. There is model number 1 is a single irrational number. You will be given like this. Prove that root 2 is irrational, root 3 is irrational, root 5 is irrational. Sometimes you will be given a rational and irrational product. Prove that 3 root 5 is irrational, 4 root 7 is irrational. Okay, this is model 1. And the model 2 is, what is model 2? So model 2, you will be given an irrational number and a rational number, combination of irrational and rational. Okay, so then that may be sum or that may be difference. 2 root 7 minus 6, 5 plus root 2. Prove that 5 plus root 2 is irrational. Okay, so this is a model number 2. The model 3 is, what is model 3? It will be given sum of two irrational numbers or maybe difference of two irrational numbers. Okay, so most of the times you got this problem in examination. Yes, so this is most important. It's model 3. Okay, so here this model 1 maybe you may not get for 6 mark question, that will be given into 4 marks questions. Model 2 also, and so this is most important, model 3. And if you, but you have to learn all these models, so we can't expect what you get in the examination. Let us go with first model, that is model number 1. The question will be given like this. Prove that root 3 is an irrational number. So you'll be given a question like this. So these all proofs are made in the method of contradiction. Method of contradiction means first of all we opposite the statement. We oppose the statement means we write let root 3 is a rational number. Okay, so it is given irrational, so we take root 3 is a rational number. Okay, and we prove that our assumption is wrong. Our assumption is wrong, so given thing is correct. Okay, so here that is called a method of contradiction. Okay, so let's start with first one. So in the method of contradiction, first of all we have to write the negative statement which opposes the given statement. So here let root 3 is a rational number. So when it is a rational number, compulsory we should write that may be that can be written in the form of p by q or a by b. The root 3 equal to a by b, where here what are a and b? This a and b are co-primes. You know that every rational number can be written in the form of p by q or a by b, in which a and b are co-primes. That is simplest form. Okay, and a comma b are integers. One more condition also you should write, b not equal to 0. Why? Because if b is 0, then this is not defined. So the irrational number, when this is a irrational number, that value will not be infinite. Okay, so here that is first one. So now this part is completed. This is assumption part. Okay, now this is step 1. Everyone should write the step 1. Okay, now here after that what we do now, so we transpose this b to left side, we get b into root 3 or root 3 into b equal to a. Okay, now we do squaring on both sides. So we get here root 3 into b whole square equal to a square. So 3b square equal to a square. A square is there, root 3 square is 3 and b square is b square, okay, equal to a square. Now what you can write here, actually here 3 is a prime number. Yes, 3 into some number equal to, you're getting a square. 3 into some number means, for example, see 3 into 5 equal to 15. Means what do you mean by that? 3 into, we are writing the product of 3 and 5 and we are getting result 15. So here you can tell that 15 is divisible by 3, means 3 divides 15. 3 divides 15. So in the same way, here you can write 3 divides a square. 3 divides a square. Therefore, 3 divides a square. That implies, so what you can write? 3 divides a also. Three divides a also. Okay, so here let us take this statement as 1. Okay, now here 3 is dividing a. Okay, this is according to the theorem number 1.6. When 3 divides a square, 3 divides a also. Okay, now I think you understood what process we are doing. Now we thought that here we assumed that a and b are co-primes. Now what we're going to do, we prove that a and b are not co-primes. Okay, why? Because here we got 3 is factor of a. In the coming process, we get 3 is also factor of b. Okay, how we get that? Let us see. Now here we can take 3 divides a, so what you can write, 3 into some number p equal to, okay, or you can take c, 3 into some number c equal to a. Why? Because 3 divides a, so 3 into some number compulsory you should get that a. Now squaring on both sides again, I'm writing here on the right side, squaring on both sides. Again 2 times we have to square in this process. So here we get 3 into c whole square equal to a square. In the place of a square, you can write 3b square. Okay. So you can write here 9c square equal to a square. What you can write? A square equal to 3b square. Since you can write here 3b square equal to a square. Now here 9 is you can transpose this 3 to left side. We get 9c square by 3 equal to b square. So 3 3s are 9. We get 3c square equal to b square. Now again we got 3 into some number b square. So therefore 3 divides b square. So 3 divides B also. This is statement number 2. So now we got what you got, 3 is dividing A and 3 is also dividing B. Okay. So now what you can assume, what you can write, so what you can write here, that is 3 is from statement number 1 and 2, from 1 comma 2. 3 is dividing right here like this. 3 can divide A and B. So A comma B are not co-primes. But this contradicts our assumption. Okay. So here this contradiction is arisen because of our assumption. So our assumption is wrong. So what is it? What is our assumption? Root 3 is a rational number is our assumption. So our contradiction is wrong. So what you can say? Root 3 is irrational. So here what you can write? 3 can divide A and B. So A, B are not co-primes, but this contradicts our assumption. This contradiction is arisen because of our assumption. So our assumption is wrong. This statement you can write in your own way also. Therefore, root 3 is irrational number. That's all. Okay. So this method is useful for any proving any irrational number. Means root 3, root 5, root 7. We do the same process. For example, if you take root 5, we assume root 5 is rational number. Root 5 equal to A by B. So then we get root 5 into B equal to A. Okay. So root 5 into B equal to A. Next, squaring on both sides, we get 5B square equal to A square. Yes. So here, now you can write 5 divides A square. So 5 divides A also. 5 divides A also. So here, this is symbol of division. 5 divides A also. And again square. Again what it assume 5 into C equals A. Now squaring on both sides, we get 5C whole square equal to A square. So we get again 25C square equal to, in the place of A square, what you can write? 5B square. So we get 25C square equal to 5B square. With 5 we can cancel this. Now we get 5C square equal to B square. So 5 divides B square. 5 divides B also. Okay, now 5 divides B also. So 5 is dividing A, 5 is dividing B. So 5 A and B are not co-primes. So this is contradicting our assumption. So this contradiction is arising because of our assumption. So our assumption is wrong. So given statement is correct. So root 5 is irrational number. Okay. So this is the first model. In the next video, I will explain the next two models. Thank you.